Hi, yeah, I'm a professor at the University of Arizona at the Lunar and Planetary Lab. I'm the principal investigator of the HiRISE camera, which is orbiting Mars right now and takes high-resolution pictures of the surface. And I'm also involved as a co-investigator in the CASSIS camera, which is on the Trace Gas Orbiter, another spacecraft that's orbiting Mars right now. And most of the research I do is about Martian climate, especially ice on Mars and what it means to see ice in different locations and the climate records in ice. Surrounding the sun is this like cloud of comet-like objects, and they were thrown out to very great distances from the sun during the formation of the solar system. As the giant planets moved around inside our solar system, we think all these very small objects got thrown out into a cloud around it, and a lot of them got thrown out of the solar system completely. So this probably happened around other stars as well in the galaxy, and so these small comet-like objects are being tossed out of these solar systems early in their history, and then they wander through interstellar space for billions of years. And we think this object, 3I Atlas, is one of those cometary refugees, if you like, from another solar system. And it's been probably wandering through space for a little over 10 billion years, and that's just based on the direction that it came from. And so trying to make a guess at which star systems it might have come from. So after about 10 billion years, it just happens to make a close flyby our sun and some of the planets in our solar system so we can observe it. You know, that's a really good question because in many respects, it's a lot more ordinary than the other two were. So among the other two, there was an object that had an extremely unusual aspect ratio, like very long and thin, whereas 3I Atlas doesn't look unusual in that respect. And one of the others broke up and had some unusual colors, and 3I Atlas doesn't seem to have anything like that either. So of all of the ones that people could have picked to attach conspiracy theories to, this one is perhaps the most typical and the most normal looking of all of them. So yeah, I honestly I can't tell you why people have latched onto this particular object as you know worthy of conspiracy theory, but it's definitely not an alien spaceship. The camera itself is like a big telescope, and telescope mirror is like about this big across. It's about half a meter or like a foot and a half across, and we point it straight down at the surface, and we can see things the size of a large beach ball or a coffee table. So it takes like really high resolution images of the surface, and it's designed to look at like really bright things that are moving really fast because we're orbiting Mars at maybe 2 miles per second, along the ground, and it has to take images of these very small features really quickly as we zoom overhead. So it's not at all well designed for observing something like 3I Atlas, where you really want to just stare for a long period of time at something that's really dim, like what a regular astronomical telescope on the Earth does. The HiRISE camera is a little bit out of its element here in trying to observe this object. But we were the closest camera of that size, and because we are so much closer, the HiRISE images are roughly about the same resolution as the Hubble Space Telescope images, or even perhaps a couple of times better. So it was definitely worth attempting. So to do that, we had to flip the spacecraft upside down, so we're looking away from Mars instead of at it. And then the spacecraft has to move over to point to 3I Atlas, and then it has to sweep our field of view of the camera like over and back across the object for us to be able to take pictures of it. And so like we're talking about something that's like the size of a grain of sand that's 100 feet away or something like that. It's just a very small patch of sky. So it's definitely a very challenging observation. Oh, we're just better at spotting and finding them for sure, and that could just take off exponentially very soon. There's a project called the LSST project, and that is associated with the Vera Rubin telescope, and they'll soon start imaging large sections of the sky down to very dim objects, and we could potentially be discovering a lot of these objects in the near future. So it's making its closest approach by the sun already, and I think we're getting our best views from the Earth about now, and then it's going to swing by Jupiter on its way out of the solar system. As it moves away from the sun, its cometary activity, like all that dust and gas that's coming off right now, is going to stop, and it will go back to just being like a single point, how it started off, and then eventually it will get too dim for us to see anymore. So we can probably see it for a few more months, and then it will be back off into interstellar space. Because it came in at such high speed from another part of the galaxy, it's able to escape the sun's gravity and move out, and it will maybe pass by another solar system in some other part of the galaxy later in its life. Oh yeah, that's a great question. I mean, I always liked astronomy as a kid, and I thought I would do astronomy, use telescopes on the Earth. But then I got involved in a mission called Mars Polar Lander, which was supposed to put a lander on the surface of Mars. And unfortunately, that mission didn't work out. The lander crashed, but I got to play a part in like choosing the landing site. One person out of very many doing that, but it was enough to grab my attention. And from then on, I was really like hooked on Mars missions and going to explore Mars.